question 8a, a student carried out 4 reactions with dilute acid A shown in the diagram. Name dilute acid A. So what we can see is that when we form salts, that the second part of the name comes from the acid. We can see in all 4 examples that the surname of the salt is sulfate, which means the acid that we've been using is sulfuric acid. Name gas B. So what we can see is we have magnesium plus sulfuric acid, which would produce magnesium sulfate, and the gas that would be produced when we have a metal plus acid is hydrogen gas. Sodium carbonate is added to dilute acid A until the reaction is finished. Other than measuring the pH, suggest how the student would know when to stop adding the sodium carbonate. What we can see here is a byproduct of this reaction is carbon dioxide. So what we could do is we could wait until all the bubbles had stopped, that's the bubbles of carbon dioxide being produced, and that would allow us to know that the reaction had came to an end. In all of these reactions, a salt is produced. State which of these salts would be produced as a precipitate. You may wish to use your data booklet to help you. So if we look up on page 8 of the data booklet, this tells us the solubilities of salts. And if we look up magnesium sulfate, copper sulfate, sodium sulfate and barium sulfate, the only one that comes in as insoluble is the barium sulfate, which means it would be a precipitate. Unlike the other reactions in the diagram, the reaction between magnesium and dilute acid A cannot be classified as a neutralization reaction. State what is meant by a neutralization reaction. So a neutralization reaction is when you have an acid reacting with a base. Written 9a, xenon is an element found in group 0 of the periodic table. A number of isotopes of xenon exist. State what is meant by the term isotope. Isotopes are atoms that have the same atomic number, so the same number of protons, but a different mass number, which means it has a different number of neutrons. The elements in group 0 are known as the noble gases and are all very unreactive. Explain why the noble gases are unreactive. All elements want to have a full, stable outer electron shell like the noble gas elements found in group 8 of the periodic table. Under certain conditions, xenon can form compounds. Xenon hexafluoride, which has the formula XeF6, is made by reacting xenon difluoride with fluorine using a nickel 2 fluoride as a catalyst. Writing the chemical equation using symbols and formula to show the reaction. So what we're looking at is xenon hexafluoride as our product, so we'll write that on the right hand side, which is given as XeF6. The reactant is xenon difluoride, so we can see that that's got a prefix, so we say what we see. So the formula for that would be XeF2. Plus it reacts with fluorine, which is a diatomic element, F2, and this is how we would write this chemical equation. Xenon hexafluoride is a solid at room temperature with a melting point of 49 degrees Celsius. State the term used to describe the structure of xenon hexafluoride. Now, because it has a low melting point, that tells us that it has to be covalent molecular, as covalent molecular molecules have low melting points and boiling points, and this is because their weak intermolecular forces, that's the bonds between the molecules, are being broken. When making a sample of xenon hexafluoride, 35 grams of nickel 2 fluoride is required to catalyse the reaction. Suggest what mass of nickel 2 fluoride in grams should be present at the end of the reaction. Because the nickel 2 fluoride is the catalyst, catalysts are not used up, so we should have 35 grams at the end. Calculate the cost in pounds of purchasing the required mass of nickel 2 fluoride if nickel 2 fluoride can only be bought as a 10 gram tub for £69.40. Now, because it can only be bought in 10 grams, we've got to have a total of 35, which means we would have to buy 4 tubs. So if we do 4 times £69.40, that would give us £277.60.